The light bulb is a very common item in our daily life, but its invention lit up our world. The light bulb was invented in 1854 by Heinrich Jiebel and improved by Thomas Alva Edison into the incandescent lamp. This is a desk lamp commonly found in our homes. We can control the bulb's brightness simply by adjusting the knob on the lamp. So what does the dimming circuit inside the lamp look like? Today, let's explore the dimming circuit. Let's assume this bulb operates at 12 volts. To make it light up, just connect a stable 12 volts power supply across its terminals. To change the brightness, the simplest way is to add a resistor in series in the circuit. So the resistor shares part of the voltage, reducing the brightness. By changing the resistor's value, we can adjust the brightness. To make brightness adjustable linearly, we replace the resistor with a potentiometer, then we can adjust the brightness by turning the potentiometer knob. Although this method is simple, it has major drawbacks. The current potentiometer has a resistance of 10 ohms. If the current is 500 milliamps, the potentiometer will drop 5 volts and consume 2.5 watts of power. This causes significant power loss, and the potentiometer may easily be damaged due to overheating. So is there a more efficient way to adjust brightness? In an earlier video, we talked about MOSFETs. A MOSFET acts like a switch. As long as we apply voltage to the gate, it switches on and off very fast, up to hundreds or even tens of thousands of times per second. Let's see what happens as we gradually increase the switching frequency. Here's the waveform you see. A high level makes the source and drain of the MOSFET conduct, while a low level turns them off. This is a 1 Hz switching frequency. This is 2 Hz. This is 5 Hz. This is 10 Hz. Here the bulb flickers 20 times per second. Our eyes can already see the bulb flickering rapidly. When the flickering reaches 100 Hz, we can no longer see the flicker, because our brain takes about 0.02 seconds to sense changes. Even if we increase the frequency more, we won't notice changes, but we'll notice the bulb is now only half as bright. So how exactly do we control the bulb's brightness? We need to understand another concept, pulse width modulation (PWM). Here is one cycle from the previous waveform. Assume the high voltage is 10 volts and the low is 0 volt. If each lasts 50, the average voltage at high frequency is 5 volts. If the high voltage lasts 60% and low 40%, the average voltage becomes 6 volts. If high voltage lasts 90%, the average is 9 volts. This ratio of high time to the full cycle is called duty cycle. So by changing the duty cycle, we adjust the average voltage. This method is called pulse width modulation, or PWM. In this dimming circuit, we input a 1000 Hz pulse signal. So the brightness depends only on the average voltage. Higher average voltage means brighter light, lower means dimmer. Here's a quick tip, even though we can't see flicker above 100 Hz. Low frequency PWM can still harm the eyes. The national standard for eye-protecting lights requires over 1000 Hz. So check the dimming frequency when buying such lamps. Now that we understand PWM, what component can generate adjustable PWM signals? Let me introduce a famous chip, the ME555. Here's a simplified internal diagram. By adding just a few resistors and capacitors, it can output various waveforms. In this circuit we want the MI555 to output a 1000 Hz square wave with adjustable pulse width. Let's build the circuit. We connect the bulb in series with the MOSFET's source and drain, and then to both ends of the battery. Pin 3 of the MI555 is the output pin. We connect pin 3 to the MOSFET gate and place a resistor between the gate and ground to enable fast switching. Pins 1 and 8 are for power. Connect them to the negative and positive of the supply. The rest of the circuit adjusts the MI555E's waveform. Understanding how it works requires knowing MI555E's internal structure, which we'll cover in the next video. For this video, focus on understanding how PWM works. Once the circuit is built, we can adjust the pulse width by turning the potentiometer. Alright, thanks for watching. See you in the next video.